stop share. Sir, shall we start?
Absolutely. Please go ahead. Thank you.
So, Dr. Priya, you can take over.
A very warm welcome to everyone. Thank you for joining us over the weekend. On behalf of ASCII, I welcome all of you to this webinar, which is a part of our CVS learning series. So this webinar is focused on biosolid standards for safe reuse and circularity. I'm Dr. Priya Sharma, working as Senior Research Fellow at ASCII. So as a researcher during my PhD, I worked on different generation toilets, different technologies, but the one thing which was very common was that the focus was always on the wastewater. So how the wastewater or used water can be treated and reused. But there was never a question about the leftover sludge, what to do with that sludge, because sludge is equally important as wastewater to bring the complete circularity. So therefore, our aim today through this webinar is to discuss the need for sludge standards in India or South Asia. What are the international norms, a roadmap for developing these standards, and the treatment technologies for the safe reuse. So I am pleased to share that we have received 400 plus registrations from India and beyond. This kind of participation and support encourage us to bring more such interactive platforms and webinars. So our panel today has eminent speakers from the government and private sector who will be sharing their experience. We are glad to have Dr. V.K. Chaurasia from CPHEO Mahua. Dr. Chaurasia advises the ministry in all the technical matters pertaining to public health and environmental engineering. Then we have Ms. Mafalda A. Pinto from Water Sanitation and Specialist in ADB. She joined ADB in 2020 as a young professional under the South Asia Department. She is a civil engineer by profession with experience in municipal wastewater treatment. Then we have Dr. Rajoshi Banerjee, who is Assistant Professor at ASCII. And then we have Mr. Veer Lakshman Bhagavati, who is the head of inclusive business from Covestro. He has an experience of over 30 plus years with chemical industry across the Asia Pacific region. Then from Shiv Shakti Enterprises, we have Mr. Venkat Rao, who is the Chief Production Officer. He's having 35 years of multifunctional experience in petrochemical, sugar, alcohol or ethanol manufacturing industries. And then we have Mr. Lalit Motwani from SFC Environmental Technology. He's the Senior Manager Marketing. And he has worked on different solar sludge drying systems in Germany and in South Korea. So they'll be talking about the different treatment technologies. So thank you for accepting our invitation. And to make sure we are helping you as best as we can on this webinar, please you can use the chat box to drop your questions and share your experiences. We would be sharing the recording, all the PPTs or any other material that you requested with you. So without any further delay, I will be handing over to Professor Chari, the Director of Center for Environment, Urban Governance and Infrastructure Development and CEO, WASH Innovation Hub at ASCII, to set the context and formally invite the speakers. Over to you, sir.
Thank you, Dr. Priya, for wonderful introduction to the whole event. And also thank you all for organizing this initiative. This is one of a very important area that we are discussing, and I profoundly thank all the speakers, but particularly Dr. Chaurasia, have taken time out on a weekend and agreeing to share his own perspective as a keynote speaker. Now, friends, let me take this opportunity to set the context and also moderate this conversation. While the National Ministry is already making a significant inroads in terms of notification of standards, promoting circularity on different streams, wastewater is already a big agenda. Used water, as we say, a lot of initiatives are happening, a lot of projects are coming through tertiary treatment and recycling and reuse. Likewise, we want to have a similar enthusiasm, similar traction for biosolids or sludges. Now, it is in this context that I would share with you the context as well as moderate this session. So today's conversation, friends, is about what do we learn from international community on the standards, what we can learn, what are the experiences, and how do we promote recycling and reuse of biosolids, which are often discarded on agriculture lands or even in water bodies without proper consideration in terms of treatment. Now, just to set the ground rules, we often use sludge and biosolids as interchangeably terms. These terms are often used in a very casual way. Basically, the sludge is something solids separated out from the treatment of used water treatment plants, STPs, and also coming in the form of septage from on-site sanitation systems, be it septic tank or pit latrines, mostly from some of the old single-use pit latrines in particular. So those are typical sludges. It has solid content, it has certain amount of moisture. Now, when you say biosolids, we are speaking about treated sludge that meets the environmental standards for land application or any surface application. Now, in absence of environmental standards, there are no incentives for us to convert sludge to biosolids. It could be potentially discharged in water bodies or discharged as land application without due consideration from environment and public health factors. So it is in this context that we are having this conversation. These numbers are put together by our team. I mean, this may not be super accurate, but if you look at the gravity of the situation, we have built large number, more than 60 lakh individual household toilets in urban areas, more than 6 lakh public and community toilets. And we also built a lot of individual household toilets in rural communities. Now, while SBM 1.0 or SBM focused on building the infrastructure in terms of toilets, SBM 2.0 is phenomenally making efforts to establish sewage treatment plants, co-treatment plants, fecal sludge treatment plants. Our number estimate that we would be adding large number of STPs in small and medium towns apart from large cities. We are also going to add a lot of FSTPs, already added quite a few FSTPs. Now, the culmination of this creation of infrastructure, while we are looking at treatment of liquid waste through this treatment infrastructure, often the sludge coming out of these treatment plants are, which is actually large in volume. Our estimation is that more than 55 lakh KLD of sewage sludge and about 25,000 of septage sludge is coming out every day or would come out with the creation of these infrastructure projects in the country over the next 3 to 5 years. So where is this sludge going and what are the characteristics of this sludge? Now, if you look at this sludge just coming out of these treatment plants, there are some good aspects of this sludge and there are not so good aspects of this sludge. The not so good aspects presented in red color or in different color as compared to the green. If you look at STP sludge, it could have heavy metals, it could have pathogens, it could have trace organic pollutants like pesticides because of the runoff. But definitely, most important thing is that it has very, very positive aspect of it. It has carbon, it has micronutrients, it has macronutrients, which can be gainfully used for various applications. It could be for agriculture or non-agriculture applications. Now, the question is, how do we make sure that these two aspects, the nasty components are treated properly and the good aspects are retained properly so that it can be used, it can go back to the nature instead of going into water bodies or into agriculture applications in an indiscriminately, unregulated, non-scientific way. So in order to do this, in order to regulate all this, we need good quality standards. The standards primarily for nasty constituents point of view and ensuring that the good components are retained for upcycling. We also need frugal technologies which will not cost us too much, but ensure that these technologies enable us to meet the standards. We need good monitoring protocols and laboratory support systems, and we need innovative financing like carbon credits and blended financing and so on and so forth. Now, today, this conversation, we would focus on standards and we would focus on frugal technologies to meet these standards. Subsequently, we will bring to you the monitoring protocols, laboratory practices, and financing models. But our primary focus is on the first two, which is the standards and technology solutions that are available, which are cost effective to deal with the bad components and retain the good components of the sludge, making it really biosolid. So friends, this is the context for our conversation. As I said, the national government through CPHO, Ministry of Housing and Urban Affairs, and the other line ministries already thought through this problem. They have created working groups on circularity. They are working towards standards. Namami Gange is also collaborating with the ministries to come up with their own standards, which are going to be hopefully notified as national standards. So without taking much of this time, I would now invite Dr. V.K. Chaurasia, Joint Advisor, CPHO from the Ministry of Housing and Urban Affairs, to give his keynote address. Also, give us what's happening at the national level, sir, and also what's your advice to cities as well as all the partners who are very keen to find technical solutions to solve the problem. Over to you, Dr. Chaurasia.
Thank you, Professor Charit. Thank you very much. In fact, when you invited in this intervening period, so many other activities were going on, but this topic is so important. This topic is so important that, in fact, we should have convened similar type of I say webinar or workshop, because this is development of this standard is being monitored at various level in the government. You are very well aware the importance of this topic, that as high as Honorable Prime Minister in first week of January chaired a meeting with Chief Secretaries of the states, that highlights that how much Government of India is giving this priority. So this is definitely going to be a very, very important, I will say, session, because already there is Ms. Pinto from ADB and all our Indian experts are there. They are working in this field. So really, I thought let it be a learning experience more than what I'm going to share. But of course, whatever the developments are there that I'm going to share. But based on their national, international experience, I would like to see, I would love to know that which way to go after I'm telling that where we stand. So that will be one thing where I will be invite not only from panelists, also from the, I will say, participants to advise on that. Regarding this importance of this topic, as I mentioned, waste to wealth and circularity, it is in top of government agenda. And apart from this Chief Secretary's meeting, there has been high level meetings and monitorings in Niti Aayog. Because from 2017-18, I remember from that they engaged with European Union to identify that how circularity in the waste can be promoted. And at that point of time, one good document came as a resource efficiency in C&D waste. And after that, maybe you all know that national policy on resource efficiency also draft circulated to do that. These all activities show that Government of India is taking it at a serious level. And apart from that, another very important phase came there. Niti Aayog identified 11 sectors, 11 potential sectors. That includes municipal solid and liquid waste also. In fact, it is on the top of that and accounts for majority of the potential of circularity here in form of wastewater, as you rightly mentioned, and in sludge also. So a lot of systematic work has gone in this circularity of water and sludge, and Ministry of Urban Development along with stakeholders prepared a detailed action plan in solid and liquid waste both, and not only action plan but also identified the gaps that are there in policy level, program level, funding level, or even that technological gap. These all things are very well covered, and that committee report was accepted by Niti Aayog, and it is under implementation, and with all stakeholder ministries, the timeline and tasks are given, and that is being monitored on quarterly basis. This development of standard for biosolids is also one important part there under that committee report and also under the action plan. So naturally, we are working on it, but the situation is already that backup data was not there with us. Because if I see in the, let us say, what was in our earlier documentations, so in FCO, it was for city compost. It is more or less similar to that. But because of its origin from sludge and sometime apprehensions of heavy metals, Ministry of Agriculture, which is administering them, readily they are not able to accept and incorporate in fertilizer control this order. That is for 2009 and 13. We repeated made effort because our interest was once it comes in that FCO, there is MDA market development assistance is available that will immediately in no time promote it to take it to field, and then market development and all players, everything will be done. But they want a concrete standards, notified standards that they can take there, and that required some supporting study, supporting document, which readily it was not available. If you see that manual on sewage and sewage treatment, a very revered document and well accepted document, there these things are mentioned that these heavy metal and all other concentrations are already given. Even that coliform and other levels are also given, but this is not adequate to let us say satisfy requirement of Ministry of Agriculture and Fertilizer. They want that through a proper study characterization, this should come along with recommendation from ministry, then they will discuss and incorporate. So anyway, here also again we are working, as I mentioned, ki circularity and waste to wealth is on the top of agenda of government. So in parallel with the again help of European Union, Ministry of Jal Shakti has developed a framework, national framework for reuse of treated wastewater. There also they touch that, but since because of want of this backup data, this could not come in that framework, but it encourages that treated sludge should be beneficially used. So that document is accepted by government, is under, and also it is under implementation. Apart from that, in parallel, apart from Ministry of Housing and Urban Affairs, Ministry of Jal Shakti through NRCD, they are having one MOU with JICA, Government of Japan. They are in this 3-year study. They are going to extensively study in India and also in Japan to develop these standards. But the challenge is this, given the pace of implementation and priority in the government, this 2-year, 3-year time is too huge. So what to do so that quickly we can do something. So one of my objective was there, because national, international experts are there. Already many participants are there who may be doing PhD, or they might have come across all these things. So if they can suggest how to go about and even develop a interim standard for which at least we can promote and advocate that, okay, you treat up to this level and we can go ahead with that. And that can be substantiated with thorough study, let us say in a year or two. Because already on study part also, Ministry of Jal Shakti has taken initiative, and NMCG along with CPCB and IIT Roorkee, a project is already underway, and they have, I think, already completed testing of some 11, 12, or I even it is more, I exactly don't remember number, of the plants where characterization of sludge they are doing. So that report will also be helpful. Given all these, I will say, background, the one thing that is finally coming, that to develop to a level of standard, how quickly we can do, what we should do so that it come in place, and then we can move forward. And whatever government support in form of MDA or other forms are there, we bring it, mainstream it. Here I would like to learn from you people what are the suggestions, and whatever the material is available, please send to ASCII, because they are our reward our partner, and we will definitely after this webinar try to explore that, given all this information, whether some acceptable level, even if FCO doesn't accept, some interim acceptable level things can be developed, so that later on it can be notified following the due process. So this was the reason I wanted to interact. I am very much thankful to all audiences and all speakers, and especially Professor Chari and ASCII team for giving me opportunity to learn this and implement in our program and policy. Thank you so much. Thank you.
Thank you, sir. Thank you very much. You have given us the efforts made at the national level, and also encouraged us to start looking at, as an interim, we can create some protocols, and while the research gets developed over a period of time, we can convert them into standards. So I think this is a great suggestion. It's a good transition from moving from not having anything to gradually improving the situation, and then over a period of time, build the credible data and research, and then notify the standards. Thank you very much, sir. Now, before we get to know some of the international experiences from Ms. Pinto, we will do a bit of a Q&A, sort of a checklist to test where we are right now. So, Priya, would you like to run the poll among all of us?
Yes, sir. Yes, sir.
We'll just do a quick poll before we hand over the mic to Ms. Pinto.
Yes, sir. Sharing the first poll question.
Yep. So the question is about which countries in the world have notified standards for sludge from STP, FSTP. So is it the European Union, United States, Bangladesh, Australia, Nepal, India? Which country among the list given have notified proper standards for sludge coming out from STP or FSTP? Okay, so we do have a fairly good participation. Dr. Banerjee, would you like to respond? Anyway, he is going to cover some of these standards, global standards. Would you like to comment on this?
Yeah, just to give in line, yeah, the people who have responded, around 74% who have said European Union, United States, Australia, you people are correct. But when it comes to India, Nepal, Bangladesh, I guess we still do not have any notified standards for sludge or sludge management. We have for wastewater management, we have standards for effluent output standards in terms of water, but exactly for biosolids, we are still to come up with one. Yeah.
While some pollution control boards do notify standards at the local level, but is yet to evolve. Next question, Priya. Okay, what are the high-risk constituents of untreated sludges? Pesticides, pathogens, heavy metals, all the above, none of the above. Okay, Dr. Banerjee, again, over to you.
Yeah, the correct answer is obviously all of the above. A prime concern being pathogens and consequently the heavy metals and pesticides. Yeah, as polled, yeah, we got around 75% with all the above, and we are bang on correct on that.
Yeah, this is a way of sort of reinforcing. It's a collective learning. That's why we are doing it. It's not that we don't know, but it's a way of sort of communicating the same message again, so that we come up with solutions. Next. Okay. What are the beneficial constituents of sludge? You can choose more than one. Zinc, arsenic, nitrogen, potassium, phosphorus. Okay, so what are the beneficial constituents? Like a lot of people have responded. Yeah.
Yeah. So obviously, nitrogen being the first, NPK in that order, the last three. These are the prime macronutrient constituents. We'll be speaking about it more later. Zinc is an essential micronutrient, but then it is needed in very minimal amounts. Arsenic is also a micronutrient which is required, but then beyond a certain limit, like more than 50 ppm per kg of biosolids, it's hazardous. So that's something not taken off.
Okay. Next. Can we use untreated sludge for growing edible crops? Okay, so I think many of you said no, some of you said yes. So we would hear more from the subsequent speakers how biosolids are used or post-treatment, how they're used for agriculture application, what sort of agriculture practices are followed in Asian countries and in European countries. So we will discuss more about it. So Priya, we can stop the poll. Now I invite Ms. Mafalda to speak about what sort of enabling environment conditions are prevalent for usage of biosolids in Asian context and beyond? Over to you, Ms. Mafalda.
Thank you. Thank you so much, Dr. Shari, and good afternoon, everyone. Thank you all the ASCII team for hosting this very timely event and for inviting me to participate in it. Could I think I can't see my presentation yet.
I'm sharing them.
Why can't I see it?
Mafalda, would you like to share it, or Priya, are you sharing?
Sir,
Can you see my?
We are sharing. We are sharing.
Okay, go ahead.
Sorry, I can't see it.
No, just give me a minute.
Okay, now I see it. Okay, great. Thank you. Great. Okay, here we go. Thank you. So, yes, I'll be speaking about the enabling environment on the biosolids reuse in Asia. So maybe next slide, please. Great. So I'm not going to repeat that much. The options for biosolid reuse, we can use it in agriculture as surface disposal for soil regeneration, or in industrial processes that might be, cement production, or as a last resort, incineration. But we need standards for each of these types of reuses to guarantee protection of public and environmental health. And in the next few minutes, I want to focus on the options that are more related to agriculture. Next, please. Okay. So this graph combines data from the International Fertilizer Industry Association, NFAO. It compares the production of the use of fertilizer, compares the production of food and the use of fertilizer in South Asia over the last 50 years, more or less. And to clarify in this context, I'm referring to India, Bangladesh, Nepal, and Bhutan. What I wanted to show on this graph is that we can see that the gap between the crop production and the fertilizer usage has been steadily decreasing more or less since the mid-70s. And this points to loss of soil fertility. And this is especially important in this region, given that it accounted between 2016 and 2018 for about 50% of the fertilizer consumption in the world, but a bit less of the world's food production, only about 10%. So most countries heavily subsidize synthetic fertilizers. Therefore, this growing use of synthetic fertilizers will correspond to an increased expenditure by governments. And this loss of soil fertility relates to the overexploitation of the soils and overuse of synthetic fertilizers. So in the healthy soil needs about 4 to 5% of organic matter in the structure, but in South Asia, the organic content of the soil is lower than 2%, and in some areas it reaches only 0.5%. And this is where the biosolids become important. And then there are issues that Dr. Shari mentioned earlier. There's issues around emissions, the use of fossil reserves for the production of synthetic fertilizers. I could speak about this for days, but I won't. Don't worry. So the next slide, please. This is a graph I'm sure you're all very familiar with. And we know that traditionally human waste has been used in agriculture, but public health concerns and also the advent of synthetic fertilizers made this practice falling in disuse. What I wanted to focus here is that some of the best data that we have is only about access. We are not even very sure how much of the human waste that is being produced, how much is actually being treated, let alone reused. But what we know as an estimate, and it's already a bit of an old estimate, that we could cover about more than 2 times the amount of nutrients that are being used in synthetic fertilizers if we were able to tap into the biosolids. Next slide. Okay, so switching gears to the policies. How can the policymakers support this shift from relying solely on synthetic fertilizers to closing this nutrient loop? One of the issues of biosolid reuse in agriculture is that it lacks acceptance from farmers. Some don't believe that compost made from sludge is safe, and there might be also some religion concerns. And currently, as it has already been mentioned, there are wastewater and FSM fecal sludge management regulations, and there are the wastewater discharge standards are getting mainstreamed. But what we're missing is the biosolid treatment. So having these standards will increase the quality of the material, as Dr. Chari was saying. We will remove what we don't want, leave what we want. And then if these standards are paired with good communication and oversight of their implementation, it will increase acceptance from farmers and the wider public. I also wanted to note that there has been a recent ISO standard that has been approved for sludge recovery, recycling, and disposal. I'll copy paste the title. I forgot to add it on my presentation. And next slide. So this has been covered. The issues that we are concerned with are these in biosolids, are pathogens, heavy chemicals. There's also the issue of exposure of workers. The standards have to ensure that workers in these that are working for the production of biosolids are safe. And next. Yeah, and then these two are starting to emerge now in terms of the more scientific knowledge. The microplastics and the forever chemicals are starting to pop up in the sludge. This is where they're settled. This is still not really covered in a lot of the existing standards, but we have to start thinking that there'll have to be more research on it. So next slide, please. Thank you. One of the easiest ways to produce biosolids is by the production of compost or co-compost. These standards for the quality of compost actually exist in a good part of the South Asia region, but only in India and Bangladesh, fecal sludge or sewage are considered for the production of compost. Actually in Bhutan, they have completely banned the use of any sludge from human waste to be used in agriculture. So from this table, we see that the fecal sludge is starting to be accepted for the production of compost, but how much of it is being produced, it's a different question. And to note that this is for compost. There are other technologies that I'm sure the next speakers are going to talk about, like biochar or black soldier flies, that they're still not being included. So that's something to think about. And again, having these standards, it will be really important for the acceptance of these new materials. Next. So ADB has also been started to look into the reuse of biosolids, and mostly the first steps of the projects that we've been working on, even before getting to the legislation, is to ensure that business models around the reuse are appropriate for each specific context, because it changes, as we know. And that's what was done for Baliwag. This is in here in the Philippines under a technical assistance program. Under this project, a business model was developed and included a business plan, marketing strategy, and communication plan. Then they also prepared protocols for the analyzing of the sludge and received support from the relevant government stakeholders. And then they started to work on the demand side, removing the ick factor. And this culminated on the development of a template for the creation of other business plans that can be adopted by the relevant utilities. In this case, this project, so they tested the compost, they did the pilots for some crops, but at the end they struggled with the length of the process that was associated with the registration of the compost, so that they could sell it. So this is something that has to be also taken in mind. The processes, then they have to be easy so that people can actually apply and get the registration. Next, please. And then in Mongolia, similar project. A bit later, this was more recent. I think it finished like one or two years ago, and it looked at demonstrating the feasibility of the production of compost in Mongolia, because it's also very specific context. Again, series of trials were carried out to prove that the compost was beneficial for agriculture. In this case, they also tested the production of briquettes, but they concluded that the calorific value of the briquettes was not enough to be developed into business. And this project, it highlighted the necessity of having clear ownership from the designated agencies that will be then responsible for ensuring the laboratories, testing, and the adherence of the standards. And in this case, draft project standards were prepared and were sent for the government's approval. And I'm wrapping up now. So my key takeaways is that mainstreaming of biosolid reuse is far from being, it's far from happening. That's why we're here today. The development of standards is very dependent on local context, and we can never forget the public reluctance for acceptance of compost. And hopefully this new ISO standard can be used as basis for national standards. And that's it. Thank you.
Thank you, Mafalda. I think very useful information that you have shared from the region. I would say that it would be very useful if you could share the ISO standard on the sludge. I think then
dropping
we can
it in the chat now.
That would be fantastic. Thank you very much. So, so what she shared, Mafalda, is also the global experience, but also very important. She used a case of Mongolia, where they're making progress, creating a business model, but also backing up with a good regulatory framework, which is in a draft stage, which has gone to the government of approval. I think probably we will reach out to you to understand what Mongolia government is doing, how they are dealing with heavy metals and such, some of the so-called pollutants in the STP sludge. We would like to learn from them. Thank you very much, Mafalda. Now, I invite my colleague, Dr. Banerjee, who is from ASCII, to give us a sense of, from your experience, what are the characterization of sludge, what you found, and also what are the international best practices, what are the international standards that you have found, both from, not only from South Asia, but also from European Union and US EPA, which are quite thought leadership, established many of these standards and revised them over a period of time. Dr. Banerjee was also instrumental in setting up a lab, and he's setting up a lab with our colleagues at ASCII also for monitoring the biosolids and various other environmental surveillance requirements. Over to you, Dr. Banerjee.
Thank you so much, sir. Thank you so much. Just a sec, I would share my screen.
You have about 10 minutes, Dr. Banerjee.
Yeah. Yeah. I hope my screen is visible.
Yeah.
So as Professor Chari was saying, I mean, with the amount of sludge that would be generated in the coming years, in his context setting, you had already given you the numbers. So with the number of STPs that are coming up, if I may say from a CPCB report of 2021, they say that there are already existing 578 STPs and 891 more are coming up. This is a report I'm talking of, the 2021. So 1469 STPs, along with that, the individual standalone FSTPs at the different states at different numbers, a huge amount of sludge, the right-hand side actually elaborates it, is going to be generated, and which needs, the water gets purified. What do we do with the sludge? So now to understand, like, what are the different kinds of sludge? And this is a kind of definition, a kind of description we have taken from a CPHO document, CPHEO document. So it's mainly raw sewage. If you see, look into the usage pattern or the management protocol they are asking, they are saying it could be used as soil filler, but it is not desirable. Or if it's directly a liquid sewage sludge, again, there are possibilities that there could be some kind of organic pollutants, and there shouldn't be a kind of, avoid all possible direct human contact. Or the dewatered septage sludge that is coming up from an STP after that centrifugation process or any other dewatering process, that needs to meet a class A biosolids class as has been specified by US EPA. I'll come to it. What is it? There are other procedures of attaining that. There are procedures by carrying out hydrolysis at high temperature. There is lime stabilization. There are solar drying. There is composting. Or even what is practiced generally in the STPs, where the sewage sludge after the dewatering process is left in the dried beds, open drying beds, or the heat dried sewage. Everywhere you will see there is a potential that it could be used as a soil conditioner, as a soil ameliorant, but there is a what you call condition supply. The standards or the safety is of a concern, whether it is in terms of heavy metals, whether it is in terms of other toxic chemicals, or whether it is in terms of pathogens, mainly because it concerns human beings, whether it is direct contact or the product that is coming up thereafter with the use of sludge. So having said that, how do we bring about the standards? We can break them into 5 different steps. The first is the standard must consolidate and address various types of quality-related concerns under one governing document. That's what we mean by coming kind of a institutional structure of framework. Second, the standard must go beyond more than quality control to account for the interaction of biosolids within the ecosystems within which they are being used or introduced. So that should constitute a kind of comprehensive quality criteria. And then the standard must outline the institutional structures and frameworks at the national, state, and local level that will steer the endless processes. So understanding the technical scope becomes evident, and the standard should streamline the technical scope to enhance their applicability and target emerging needs like management of humus or certain things. And then, of course, when it comes to expanding it to the geographical scope, we can start small with 1 or 2 PCBs coming up with a notification, and then proliferating it, and then with research-based evidence which can go parallel while we adopt the standards from international understandings, we can adopt the standards, start practicing them, and then we back it up with some scientific understanding of our own, which we'll carry out here in our country, and then back it up. That kind of an approach, a two-pronged approach, could be taken up. So having said that, Professor Chari already gave you the goods and the bads, what the sludge contains. We have the heavy metals. So, I mean, there's just to give you a point of amusement. Dexter, we know he's a scientist, and Dexter is asking like what the sludge constitute of. So I already gave you heavy metals, pathogens, trace organic pollutants. These are all some of the bad parts of sludge. Or organic matter, micronutrients, macronutrients. These are some of the good parts of sludge. But what are they? What are they? Heavy metals, we all know heavy metals, like they have different sources by which they enter into septage or even sewage. They enter through the different kinds of utensils we use, the rough usage of utensils we use, the different kinds of contaminated fish or meat products we eat, because the water body is contaminated, so consequently we get that, and that enters into the septage as well as the. Now, what are the kinds of pathogens that are there? Pathogens, several kinds, but mainly we would focus on bacteria. We would focus on helminths. We would focus on viruses. Helminths, tapeworms, hookworms. Helminth is a complicated name, but if I say it in terms of tapeworms, hookworms, all of us remember during our childhood, we were given doses of albendazole to get rid of these worms. They still are there. They are very stubborn cysts that stay in the soil and the sludge that go out from our body, and then they stay in the sludge. And when they get a good environment, they again regerminate and infect us. Bacteria, like a bacteria which causes Shigella, which causes diarrhea, Salmonella, which causes typhoid, E. coli, which causes different kinds of urinary tract infections. So these are some of the bacteria or viruses, the enteric viruses like noroviruses, rotaviruses, these are already there. Or if I talk of the trace organic pollutants, we already know the trace organic pollutants like the polychlorinated biphenyls, the organophosphorus compounds, the insecticides, the herbicides, or of recent, we have started becoming concerned about the antibiotic residues. Just now, Mafalda was talking about some long pertaining chemicals like the microplastics. These are all organic pollutants which are there resident in sludge. While if I talk of the good part of sludge, one is, of course, if I talk of the carbon content, then there are these macronutrients like nitrogen, phosphorus, potassium, magnesium, calcium, sulfur. These are all constituents of sludge. While the micronutrients like boron, chlorides, copper, iron, manganese, nickel, zinc, these are metals, but these are micronutrients. They actually help in the growth of plants. They actually help in the different enzyme systems of any of the living beings. Some of the enzyme systems cannot work without the presence of these heavy metals. So those are the micronutrients we require. Now to talk about, if I use that sludge rampantly, this is a collation of several literature documents we have taken from global of different parts and published in different times, where we see that rampant or unregulated use of sludge actually leads to either decrease or increase in the pH of the soil. If the pH increases too much, that is, if it becomes alkaline, it is detrimental for the plant. If it is acidic, it eats away the roots of the plant. So again, toxic elements, we already spoke of some of the, I named some of the elements. Now on the right-hand column, you actually see some of the toxic elements that are always present in sludge, but that is what we need to regulate, the concentration of that. And of course, the pathogenic organisms also I spoke, the bacteria, the viruses, the helminths. these are some things of concern which have been red boxed in this second column here. While the other ones, the other kinds of properties that are contributed when a sludge is mixed up with soil, agricultural soil, horticultural soil, the other properties like soil aggregate stability, bulk density, water holding capacity, porosity, erosion, humus, these are actually some very good contributions which is brought about by the use of dried sludge, or we may call it biosolids, treated biosolids. It increases soil carbon, it increases the soil conductance, nitrogen and phosphorus is increased, cation exchange capacity is increased. Of course, little bit is concerned about yeast population. There are certain plants which need some bit of yeast population, and aerobic bacteria, mainly the bacteria, if I'm talking of nitrogen increase and phosphorus increase, it is because of these aerobic bacteria which is there in the sludge or which is there in the treated biosolids, which helps in the nitrogen assimilation by the plants or the phosphate solubilization for the plants. Yeah, I'm just. So the sludge characters, if you see, this is an untreated sludge character. If you see the rightmost two columns, heavy metals and pathogens, in untreated sludge, these are pretty in high numbers. But if we kind of come off kind of a treated sludge, we bring down the numbers of heavy metals, concentration of heavy metals and pathogens. What goes up basically in a treated sludge is the nitrogen, phosphorus, potassium, carbon, the nutrient potential of the sludge actually goes up. Having said that, these are some of the treatment methods. There are conventional methods of drying them out in the sun. There are thermal hydrolysis, biological hydrolysis methods, whether you do it aerobically or anaerobically, thermophilically or mesophilically. There are several methods. And then there are the thermal drying process of pyrolysis and producing biochar, etc. Of some of these technologies, of course, we will be seeing it. We will be hearing from our practitioners in the later part of our webinar today. Adopting to the international standards, if I talk of the nutrients, these are already a recommended minimal level guidance, minimal concentration guidance, which is already there in the US EPA. We could actually take them. In fact, our sludge contains more of it. So these are the minimal levels. Talking of the metals, if you see some of the metals like zinc, copper, these are of higher concentration, if I may say. These are used in a higher concentration. They can be used because they are actually micronutrients, while some metals like mercury, chromium, cadmium, their levels are very low. So we could actually directly adopt them. One which is not much of concern taken in the WHO by US EPA is the fecal sludge. That is the reason we have collated the WHO fecal sludge standard solids here also, to give us an idea like what should be the range of these metals in the sludge, whether it is fecal sludge from an FSTP or a STP. And finally, our main concern when it comes to using is the microbes, pathogenic microbes, whether it is E. coli, which causes urinary tract infection, salmonella. These are some of the very easy to detect indicator organisms which we can actually implement in qualifying the standards. Total coliforms, fecal coliforms, we already practice for water. We can just shift it here. Helminths, again, a little bit of microbiological skill is required, but not a very big thing. It can easily be disseminated, trained. People can be trained about it. And enteric viruses, of course, there are many enteric viruses, but we generally concentrate on somatic coliphages, which is an indicator of viruses or enteric viruses in sludge. So we can adopt these standards directly and put it in practice. I was talking of Class A and Class B solids. Class A solids is actually when we talk of all these pathogenic indicators, they qualify for all the parameters. They comply to all the parameters and standards records set. Class B, if any of them fail, if any of these, whether it is fecal coliform, salmonella, enteric viruses, helminthova, if any of the parameters fail to comply to these stated standards, we put them in Class B. And that is the time when we have to be more vigilant on the use of it. We cannot use it for a kind of a food crop. We can use it for kind of some long-rooted crops, cash crops, or fodder crops. That is what is suggested in the US EPA or Rule 503, as they call it. Now, these are some of the understood biosolid uses, whether it is agriculture or soil rehabilitation or remediation, a kind of what we call afforestation programs in our country. We can go for composting, co-composting. Mafalda was telling that there are standards for co-composting, but we do not have it for directly use of biosolids. Mine rehabilitation, again, a kind of afforestation program that can be taken up, landscaping, horticulture. And then there are some kind of engineering applications where we can get into cement and brick making, road construction, base material for roads construction, use it, the biosolids, to convert it into energy, and finally contribute to carbon sequestration. Having said that, if we look into the way forward, collating all these standards and putting into practice by the state PCBs by publishing a notification, and then we look into adopting the standards and invite innovative technologies which will help us to comply to these standards, is what we look forward, and then strategize a monitoring capability, monitoring a system, and then finally back it up with using of these biosolids, which all finally contributes into the circular economy of our country. Having said that, I guess there would be some questions which we can take up later on in the chat box. Professor Chari, I hand it over to you to take us to the next phase of our webinar. Thank you so much, sir.
Thank you very much, Dr. Banerjee. Excellent presentation, giving a lot of facts, a lot of, I would say, experiences from different countries with regard to the standards, and giving confidence that what Dr. Chaurasia also mentioned, that I think we can take it in a sort of in a transitional way. We can start with a couple of state PCBs, notifying them, start working towards appropriate technologies, and then creating business models for recycling and reuse. Thank you very much. I will come to certain questions a little later, but just one or two points to kickstart the conversation before we move to the next segment on the treatment solutions. Why are we delaying it in notifying these standards? You said that some of them are no-brainers, straightforward, in terms of, for example, the pathogen shall not be present. I mean, it's obvious. Likewise, there are standards for micronutrients. It could be, it's already notified in the wastewater segment. Why not we just use some of the international as well as national standards with regard to wastewater and notify for the biosolids? So what is stopping us? What do you think are the main roadblocks?
One of the biggest roadblocks, as we can perceive, is initially the number of STPs were small. The sludge generation was not noticed much. Today, it's increasing volume, so people are taking notice of it. But then comes the credibility. I mean, the question of credible laboratories, one, which we have identified. Like, it's very difficult to find credible laboratories and then believable results from them. And then these, especially the chemical analysis, it's very common. Most of the laboratories, commercial laboratories, they are very, they can do it. But when it comes to these, especially these microbiological parameters, especially the pathogens, whether it is a bacteria, whether it is the helminths, this is where it becomes critical. A little bit of skill development is required, capacity building of the laboratories, capacity building of people, creating that awareness among people is somewhat, I see myself, was what is required.
Okay, so what you're saying is it's not very difficult to notify the standards, but monitoring them and ensuring that we get the right kind of standards or right kind of treatment infrastructure in place to meet the standards before we put in use for various applications is what you think is a most important thing right now.
Absolutely.
And you also mentioned that many of the laboratories are not really geared up to do this monitoring. So we need to build laboratory architecture as well as skills for monitoring point of view. In fact, Dr. Chaurasia, just to inform you, we had this problem, sir, when we were trying to monitor. We gave these samples to many laboratories, but they were giving inappropriate results which we couldn't correlate in any way. So that's when Dr. Banerjee suggested that we should set up our own lab and do R&D. And that's what he's doing right now with regard to fecal sludge and biosolids, along with Dr. Anumeya, Dr. Priyanka, and Priya and other colleagues here.
Sir, I have seen very excellent presentation and suggestions we have noted. We will speak on it, I think, side by side. Apart from implementation and notification, this ecosystem of labs should also come. We have to find out some center of excellence and proceed with that. So at least to begin with, and later on they can become a trainer of other institutions where it
Absolutely,
can be
sir.
set up.
Absolutely. Thank you very much, sir. So now we move to some of the technology solutions and business models to deal with the sludge. And there's actually a lot of things are happening in India right now. And we thought we would use this occasion to bring this information in front of you. So let me start by inviting Mr. Veer Lakshmanan to speak from Covestro. He's the head of inclusive business, and he's going to speak about nature-based greenhouse dryer as a solution to solve the problem and bring the sludge to Class A standards of Class A biosolids. Over to you, Mr. Veer Lakshman.
You need to unmute yourself, sir.
Yeah, thank you. Professor Chari, distinguished guests, fellow speakers, ladies and gentlemen, thank you very much for giving me this opportunity to talk about what we do in Covestro. Covestro is basically a German company. My presentations are there. Maybe you can refer it later. You can share it with every one of them. So prima facie, we as Covestro are a material manufacturing company, and we entered into this space of biosolids management very recently, 6 years now. And we have already established many plants across our country. So our treatments are prima facie based upon nature-based solutions. As rightly said, we use solar powers, basically the greenhouse energy, to kill the pathogens and convert this into some of the useful material. We are part of this waste to wealth program run by the government of India. And we are also part of ensuring whatever we create at the end of the day is useful to the community. And we also believe on step-by-step eradications of the problem rather than jumping into.
You want me to share your presentation?
Yeah, maybe I'll give this introduction and then we can start sharing the presentation, because I have just 10 minutes with me.
Okay.
So prima facie, what we wanted to do under this whole inclusive business is to reach our technologies into different municipalities as well as the different FSTPs. And we are working with many of the people, and thanks for all the support that we are getting from Professor Chari and ASCII as far as the implementations are concerned. So the technology is fully grown today, and it is 100% automated. It suits the demands of FSTPs, STPs, and also the municipal solid waste management. So when we talk about in SBM1 or SBM, we started collecting or containing the fecal matters. So that is the first step which we did. And we built to over 11 crore of toilets in our country, which was a great thing to do in a country of our size and our population. And under SPM2, we started treating this by putting up all these kinds of plants. As of today, we speak, we have more than 1,000 FSTPs established across the country. However, only 20% of them are getting utilized, and we needed to understand why it is not getting utilized. And there could be some problems which are related to the community, and also problems which are related to the backlashes that are coming from the place where it has been done. So which prima facie tells that there is a lot of backlash, especially to get the land that is required. This is one of the biggest constraint that we have when we use, when we wanted to put the decentralized FSTPs. But decentralized FSTPs is a lot more important for our country, for our size, prima facie, because of the quantity that we deal, and we cannot go for our 100% under the ground kind of centralized treatment plants, which is very expensive and is also quite expensive to treat them. So we need to have a technology which will be more based out of the energy that is available within our reach, that is basically solar energy. And we should also make sure all these biosolids which are coming out are treated perfectly so that we could use them for different purposes. As of today, the FSTPs that we are the sludges that are getting out of the FSTPs, we are trying to use them as fertilizers. in this regard, we are collaborating with the universities to see how we could make it useful for agriculture purposes. And primary focus is on killing off all these bacteria. And as rightly mentioned by Dr. Banerjee, who gave you a lot of list, which includes starting from the heavy metals, the pathogens, and also the fertilizers, washers that we are having. We are prima facie focusing on killing off all the bacteria and making it a Class A certified materials, which could be used as a biofertilizer. It may contain certain quantity of, I'm not denying, it may contain certain amount of heavy metals, and it may also contain certain amount of fertilizers washings, which is coming out of the excreta that is coming every day, which is quite a huge quantity that we are getting every day. And it is very important, we cannot have a 100% solution at a start. We need to go in stepwise process. And from today, we wanted to take a step positive in terms of reducing the contamination that is happening. So that is where we wanted to go with Class A as a first step to eliminate all the pathogens, and then look into the next steps of which involves a lot of cost and also a lot of energy to eliminate the heavy metals and make them like a very perfect bioconditioner, as we already talked about. And when it comes to STP, we also know STP contains quite a better amount of organic content. And it also has lots of others, which is very difficult to treat. So our recommendation for STPs is prima facie, we wanted to convert them into briquettes. As rightly mentioned, it has lower calorific value compared to a conventional coal. However, based on the regulations that has been set by the government of India, we could use 5% of the total consumption of a coal replaced with these sludges that are coming out from these STPs. So this is a kind of recommendations which we have, and we have 100% no manual intervention, no manual interface to convert the sludges into the briquettes. And similarly, when it comes the municipal solid waste, we convert them into manure because the quantity of organic materials that is present, and it is also very, very fresh. We could convert them into real good quality, what we call the organic fertilizers. These are the solutions on which we are currently working.
So, Mr. Lakshmanan, would you like to speak about how you're going to do it or how you're doing it? A bit of insight on that.
So basically, we adopt a kind of a consortium approach when it comes to execution of all the projects. So we have the basic technologies and we collaborate with the people. We don't want to do everything by ourselves. Would you like to
speak about the technology? Would you like to speak for the benefit of others? So, yeah.
Okay, so the technology what we have is is basically greenhouse effect, and I'm sure everybody knows what a greenhouse effect is. And we have quite a good quantity of solar energy that is available in our country. We use the greenhouse effect to reduce the percentage of solids and increase the temperature of this particular greenhouse. So the temperatures in our country, based on the external environment, we get to have easily 60 to 65 degrees centigrade achieved. And with this, we are in a position to kill almost every other pathogens that are available. So it is greenhouse effect supported by the solar energy, and it is 100% free from any kind of what you call the grid energy as far as this particular treatment process is concerned. And there was also one more important point that has been raised. We are also looking onto technologies which are free from any kind of what you call the microplastics involvement. So if you see today our STPs, we do use microplastics, which is used as a coagulant. We wanted to have an alternate coagulant, which is based out of neem, which is more and more an organic material, which is free from any kind of a microplastics. Yeah, and these are some of the advances which we are progressing or pursuing right now, and we should be getting into the market very soon for STPs as well. So thank you very much, Professor Chari. You want me to talk about, maybe now, if you can show some of the slides of mine, it will be very helpful. I don't want to get into the.
We have a little time. If there are any visuals to
I'll show a video. Maybe you go directly onto my last but one slide. So I have a video of the plant that has been executed in Angkol in Odisha. So maybe that will be a plant. Yeah. So can you come down to this? Yeah. Can you? Slides, yeah. This is more about my company, which which I do not want to talk about at this point of time. So you could see the kind of, this is particularly a plant which was executed. This is 100% free from any kind of grid energy. This is 100% based on solar. And we have our greenhouses, which has been established. And this helps in reducing the number of days that is required for drying. So we are reducing it by almost 50%, by which we are increasing or doubling the capacity. That's what the biggest issue as far as our country concerned is, the availability of land. So with the help of the greenhouse effect, we could reduce the land that is required and we could minimize the cost. The cost is also very, very low with the help of this particular technology. And the sludges that are coming out of this is further taken into a pasteurization unit, which is prima facie increasing the temperature still higher to about 60 to 65 degrees centigrade and killing off all the pathogens and making it very convenient and comfortable to meet the Class A standards. So this is what we do under Covestro. And similarly, we have the treatment process for STPs and also for the municipal solid waste. Yeah. And I'm available and I'm ready to take up any questions, maybe now, maybe later. And thank you so very much, Professor Chari and the ASCII team, for giving us this particular opportunity.
Thank you. So I think this is you've given the video as well as the content in terms of how the moisture content is reduced, as well as how the temperature in the system has increased to kill the pathogens to reach Class A biosolids. I think there's a concern expressed by a couple of participants that what happens to the heavy metals if they are present in the sludge. How do we deal with it? So it all depends on what is the level of presence of heavy metals and whether they meet the standards that we are discussing. So I think those questions are yet to be answered. But as Dr. Banerjee said, we need to have a good monitoring system to decide whether it can be called as which is fit for land application or agriculture application. But I think this is a good starting point where we are removing the pathogens out of the sludge and making it amenable for some of the applications. Now, we move to the next presentation by Mr. Venkatrao, is a Chief Production Officer from Shiv Shakti Group. In fact, this is an interesting experience. Mr. Venkatrao, actually, his company buys the STP sludge from Hyderabad Water Supply and Sewerage Board at the rate of 500 rupees or 550 rupees a ton. And then they process it and then add value and sell the product in the market with a bit of profit. So over to you, Mr. Venkatrao. What is actually happening? What is your process? Why do you pay money to water board to buy the sludge? So what are the economics of all this? Over to you.
Okay. Thank you, Chariji. Actually, good afternoon, all participants, and we should be thankful to all the ASCII team to giving this opportunity for us for exploring our credibilities. Similarly, we should be thankful to other hosts for giving very valuable information, like Mr. V.K. Chaurasia, similarly Ms. Mafadla Pinto and Banerjee ji and Lakshman Garu. They have given very good, especially Lakshman told about the drying process, which will be very useful in our future operations. Definitely this is a collaborative work which is required. I just brief. My name is Venkatrao, representing Shiv Shakti group of companies with a group turnover of about 800 crores. We are doing almost more than 1 lakh tons of organic fertilizer manufacturing and marketing through Navbharat Fertilizers Limited. And we have decentralized.
You want me to share your PPT?
Yeah. You can just keep the first slide.
Okay, sir.
Yeah. Through Navbharat Fertilizers Limited, we are manufacturing and marketing across India, and as a part of our new sourcing, we have been get contacted with HMW SSB, and we started working on sludge since 2016. After working about 3 years, we came to a stage that we converted that sludge into a useful material, because we are having fully equipped laboratory at 2 locations. One is at Jabalpur, and the one is at Hyderabad, near our Medchal, which is a district headquarters. Also, we have enough lands for processing that. So by with that, we have worked a lot of processes on that, and what are the any suppose heavy metals are higher, how to reduce it. It is only it is not any technology. It is just to dilution, and that process only we did adapted. Whereas in microbial process, we have done a lot of R&D, and we have we got I think later on Dr. Rajesh will share the things. And now we came to a stage. We are very confident that we can proudly extend our cooperation in this disposal process, and we can convert that sludge into a valuable compost. Thereby, we take it for enrichment and marketing. We are having a good marketing team, and you can see that slide actually here. 2020-21, almost 5,500 tons we have lifted from Hyderabad Municipal Corporation, and 21-22 almost 4,000 tons we have cleared, and this year up to now it is 3,500, and as because this is it is very low because of extended rains. Actually, there is huge rainfall, extended rainfall, and also the lot of expansion works are going on, and the place allocated was reduced by 75%. Actually, earlier when we have some 3-acre land, now because of the project expansion, the place has get reduced. So that is one reason for reducing this year. Similarly, we definitely take part into this good service to bring the environment, improving the environmental conditions. Rajesh, just you can go through that slides slowly.
Yes, sir.
Dr. Rajesh.
Good evening, all of you.
Rajesh garu, go ahead.
Yes, sir. Yes, sir. My name is Dr. Rajesh, working as an Assistant General Manager Production at Shivshakti Group of Companies. Can I continue the slide, sir? Next.
Yeah, please. Yeah.
Yes.
Yeah, sewage sludge is a residual semi-solid material produced during sewage treatment of industrial or municipal water. And sewage sludge contains decomposable organic matter, other inerts, micronutrients, macronutrients, heavy metals, and pathogenic bacteria. Next. Normally, we have characterized before composting. It is around 30 to 75% of moisture. It depends upon the separation process, and solids around 20 to 30. Heavy metals is available, as well as organic carbon is 5 to 30. pH is variable in general. Next. So we have used sewage sludge as a composting. Composting is a process, natural process. Decomposing of organic waste material, converting into useful material, using beneficial decomposing microorganisms. Next. During composting, organic matter as a food source for microorganism and converted to useful material. And during this composting, produce carbon dioxide, water vapor, humus-like materials. The capacity of microorganism assimilates carbohydrates such as cellulose, hemicellulose. And during this composting, produced various type of enzymes. Why sludge composting is necessary? Before this slide, accumulation of sludge, it creates environmental hazardous. During this composting, pathogenic microorganisms are killed, and stabilization of organic material, and reduce bad odor and generate environmental reusable material. Next. During this composting, we first of all we dry the raw material sludge around 20 to 35. Treatment with biocontrol agents to reduce the pathogen. Next, based on the requirement, we have to add organic, locally available cow dung or pressed mud. Next, composting required certain parameters. Carbon nitrogen ratio will be 25:1 to 40:1. Moisture around 35 to 50%. And oxygen is more than 5 ppm. Yeah, temperature will be 45 to 60 degrees centigrade. Next. During composting, for composting process, we record is a consortia microorganisms based on their requirement. There is bacteria, fungi, and actinomycetes. We have a specialized consortia, and we have worked press mud composting, like sludge composting. Also, we have worked so much. Based on our experience, we have made the consortia. Next. Biocomposting process schedule, first initial 10 to 15 days, we are putting windrow and reduce the moisture, then apply for biocontrol agent around 10 to 15 days. And during this process, we use aerotilling. And the next decomposition process is take 45 to 50 days. During this process, trimming and aerotilling. Maintain during this process, decomposition process. Maintain the moisture 35 to 40%, and the temperature is 50 to 5 degrees centigrade. Next, heat curing. Next. We are
okay, thank you, Rajesh.
Yes.
Actually, for carrying this, we are having huge microbial culture production centers are there. Because basically, not only for this sludge decomposing, because for our basic business of organic fertilizer across India, so we are producing our own cultures. Similarly, one thing is the treatment process, another thing is the value addition process. For that also, we are producing a lot of organisms, more than 30 microorganism bank is there with us. Also, our this biotechnology and microbial laboratory people, our R&D team, they are very strong, and we have identified a bacteria Lactobacillus, a beautiful methanogen, which was identified by us and which is registered in the World Gene Bank also. Similarly, we are also almost patented a process of in vitro mycorrhizal production, which is also we commercialized it. Actually, we are also one of the almost biggest producer of in vitro mycorrhizal fungi for agriculture use.
Venkatragaru, we need to move fast. If you could
yes,
take us through the process.
And these are all the things we are using for value addition to the base material, sir. Thank you for the opportunity, sir. Thank you.
So tell us a bit before I invite the other speaker. What is your business model? You buy from the water board? How does it work?
Yeah, actually, we made a contract. Okay. So we made a contract for 5 years. Every year, enhancement with 5% value, and whatever the collected there, that will be transported to our site.
Who will be transporting? You will be transporting, or they will be transporting?
No, we are only transporting.
So you pay 500 plus rupees, which is increasing every year, and then
yes,
transport.
Yes.
And then you transport the sludge from the STP,
yes.
300 mLD STP plant, and then you take it to your plant in Medchil, and then you add bioenzymes, and then you go through a treatment process, and then what happens?
Yes, actually, we are doing the drying process in the area itself. Because,
no, that's fine. That's fine. The process is understood. How do you commercialize it?
Commercializing, actually, it is we are selling it as organic fertilizer.
And there's good demand
and
for
city
it.
compost. City compost.
And there's good demand for it.
Yes, yes, it is good demand means actually it is a push product right now. It is just like that. If you put it in the shop, it is very difficult to sell out. But we have good team of network who is promoting continuously. There is actually in our for this purpose we are having a team of promotional who works for the promotional activities. More than 30 people are working on that promotional activity. Similarly, we are also tied up with some of the fertilizer companies like RCF. They are also approaching us by seeing our infrastructure.
Okay, and how much is what is the sale price? Somebody is asking, what is the sale price of your product? Average
sale price is starting from 170 rupees per bag. Starting from 170 till 450 rupees it is there.
And the bag size and the
bag size is 40 to 50 kg. 40 kg is there, 50 kg is there.
Okay, thank you very much. So,
Sir Chari, if you permit, just one small question
Yes,
I want to ask you.
Yes, yes,
what about the compost that you are, let us say, producing? Once it being tested, what is failure rate regarding heavy metals or pathogens? Have you any statistics?
Yes, sir. Yes, sir. Actually, basically, we are testing the material as per FCO to meet the FCO norms, because when we want to give it in the market, we have to 100% fulfill the requirement of FCO standards. So for that purpose, we are in our laboratory we can fully check all the heavy metals. Similarly, about other elemental nutrient contents also.
No, but the question is about what is the failure rate?
Failure, sir, actually what we are doing, the heavy metals, wherever there is heavy metal content is higher side, simply we are diluting with some other substrate, which is available with us, which is very low in
but
heavy
we
metal,
want to
like
understand, because
press metal.
I feel being in government, some interested groups create hype that there is heavy metal, there is this problem. When you are actually testing, what is the percentage where heavy metals percentage is more than the prescribed one? I want to understand.
Yes, sir. Actually,
if it is not readily available, please share. But let it be clear that in a particular type of town, when sludge is being taken and treated, what is the percentage solution you are making? You are diluting and selling it. That is fine. But actually,
yes,
you want to understand what is the percentage of failure.
Actually, it depends on the source, sir. Actually, because in Hyderabad, we tested with about 12 sources. 12 STPs, we got samples and we are testing it. And some of the sources is showing very high heavy metals. And some of the sources, we found the heavy metals is in par with the standards laid by the FCO. So that heavy metals, wherever there is higher heavy metals, it is nearer to some industrial areas.
What Dr. Chouras is also asking, and it's good for the sector. If we will discuss with you separately, we will get to understand more from the data point of view, what is the failure rate, and from the total samples you collect and whatever sampling you're doing. Subsequently, we will discuss this aspect, but I think it's a very useful information. Thank you very much, and we will be in touch with you. I now invite Mr. Lalit Motwani from SFC Engineering Environmental Technology Private Limited to share their experience of handling the sludge, particularly using the nature-based solutions of solar. Over to you, Mr. Lalit. Lalit, we have a bit of time constraint, so keep it about 7 to 8 minutes. Thank you very much.
Okay, sir. I will try my best. First of all, thanks for giving me the opportunity for presenting this solar sludge drying process for achieving Class A biosolids. Basically, myself, Lalit Motwani from SFC Environmental Technologies Private Limited. We are an engineering technology company. We have many technologies like CTEC, SBR, where based on which STPs are made. Then we have fiber disc filter, turbo blower, and one of this solar sludge drying process. This IST Anlagau GmbH is our collaborative engineering partner from Germany, which gives design and equipment for achieving Class A biosolids. They have more than 30 years of experience in this solar technology, and first initial installation was done in 1994. And today they have more than 225 installations worldwide. Giving you some examples, this is Class A certificate from client Bywater. It is in Managua, USA. And towards right, it is from one of our Indian STP 37.5 MLD Lucknow from IIT Roorkee. It clearly specified that the sludge which we get from this process is as per USCP standards. All of the vector attraction reductions, pathogen requirements, and pollutant limits are within as per US EPA guidelines. I want to give a gist how the system is. So it start from the sludge to the dried pellets. So the initial sludge which we get from the centrifuge is around, in the STP process, is we get around 15 to 30% dry substance. It is very difficult to handle. It develops bad odor during prolonged storage. It contains pathogens. It attracts insects, and it has limited reuse potential and consumes landfill area. So this is the output sludge, which has around 80 to 90% dry solids, reduced volume for disposal. It has density around 0.7 to 0.8 tons per meter cube. It is easy to handle. It is odor free. It can be used as a manure. It can be used as a fuel, and it eliminates pathogens. Its calorific value is around 2800 to 3500 kilocalorie per kg of dry solids. It is similar to that of lignite. For giving you some example, see the inlet sludge. What we are doing here is, suppose the input ton is around 750 tons, which has 20% of dryness. You will get output tons of 200 tons, where we have 75% of dryness. So what we did here with the system is we reduced the mass of water of around 73%. Dry solid content remains same, only the water gets evaporated within the system. So what is the basics is we are using solar drying. Solar drying is basically limited by the amount of solar radiation per meter square. What I want to explain here is the solar drying process radiation will be different in Kashmir as comparison to Chennai, as comparison to Mumbai. This radiation plus the humidity and the temperature will determine the potential amount of water to be evaporated per meter square. This mechanical dewatering is very efficient up to 25% dry solids like centrifuge, belt press. After that, solar drying is processed step after mechanical dewatering. It's like a wet cloth. First press out the water and then hang out for the drying. You do it for cloths. Now, what is the basic principle of solar drying? It's like you put the polycarbonate sheet, okay, in the greenhouse. It has better 85% heat transfer efficiency and 90% light transfer efficiency. Now, with this greenhouse radiation, temperature, and heating, the sludge surface or the water on the surface of the sludge will get evaporated. But what about the sludge at the bottom? So here comes a van der Waals machine, which it is called sludge tiling turning conveying machine. It spreads out the sludge and dewaters the dewatered the sludge and spread out the sludge, so that in the process the water gets evaporated with the help of these fans, automatically with the help of PLC. I will show you the gist. It is fully automatic. Or just a small design. We consider, we do the simulation like it is one of the Ahmedabad plant. How much is the radiation across the year? Considering you see the red line, this is the temperature, and the blue line is the humidity. Considering all this data, we run the simulation and we can get how much output you want. You design give the area and build the sheds accordingly. So here my target is to achieve class A sludge, in which minimum I need minimum 75% dryness I need. So you see this red line. This is minimum 75% dryness I can achieve in all the season across the year. So considering the worst case scenario, when in very rainy season and colder season, where the temperature will be very less, radiation will be less, in that season also I will guarantee 75% dryness with this procedure. And this blue line is the dryness across the various months across the year. So what we are doing is we put daily sludge load at one end of the drying hall. Van der Waals machine distributes, heaps, tills, aerates, and conveys the sludge. The dryness of the sludge increases when the sludge is conveyed, and it is unloaded of the then the dried sludge is kept at the other end for unloading and distributing. So here is the machine. It's the visual. It will distribute the heaps. It will come back at its original position again and again. It will happen over the period. So initially, the heaps are created of around 80 centimeter. The sludge layer is formed at the middle at around 40 centimeter, and at the end, we get the dried product of more than 80% dryness at the last of 100 centimeters. This is how the solar sludge drying look place. This is the end product of compost dried sludge of 80% dryness. I just want to give you a feel, just if you can give me a minute. Is it visible to you?
We see your slides, but we don't see the video. Are you trying to show the video?
Yeah, give me a minute.
Do
You
you
need to
want us to
bring
share?
it down.
Yeah, can you play the video, please?
Yes, please. Just can you?
Or just a minute. I got it.
Lalit, I suggest you pull down the PPT and then upload the video again.
Sir, can you see the video now?
No, not really.
Priyanka ma'am, you can share the video.
I think you will have to stop sharing the screen.
Professor Chari?
Yes, sir.
I have to leave for somewhere, some outside.
Sure, sir. Thank you very much.
Allow me.
Yeah.
Thank you.
Thank
Read
you.
now.
Yeah, go ahead.
Yes.
The strength of the sun.
It's a
In our latitude, the sun provides about 1,000 kilowatt hours of energy per square meter a year for free. We use this solar energy to dry sewage sludge with the Van der Waals system and achieve the evaporation in Middle Europe of about 850 liters of water per square meter. To start the dehydration process, the sewage sludge is brought into the drying hall. Due to the possible adjustments of feeding frequency, immersion depth, and drum rotation speed, the sewage sludge is spread out evenly in the hall and is transported lengthwise through the hall. To evaporate 1,000 liters of water, it takes approximately 1,000 kilowatt hours total energy. Using the solar-powered Van der Waals system, the amount can be reduced to 20 to 30 kilowatt hours electrical consumption. To provide the most efficient and quick dehydration process possible, the cleaning sludge is vented and kept aerobic. The air is changed through the controlled venting technique. The main part of the dehydration system is the Van der Waals. The standard widths of the Van der Waals are 10 and 12 meters.
So probably we can circulate the video to all the participants so that they get an exposure to the technology. So just before I open the floor for some conversation, we have already exceeded the time. Just one or two questions. I asked the same question what Dr. Chaurasia was referred to. What is the failure rate of the sludge that you're handling? When you pick up the sludge from STP and take it to a laboratory, does it contain a lot of heavy metals? What is the failure rate? Or the solar drying is good enough?
Solar drying is, sir, good enough. Whatever we are testing presently, we have tested a few samples. Recently, I got this report of 37.5 MLD Lucknow. We are getting better quality and all the test results are as per USCP norms. This solar drying is good enough. But if you, it is like if you operate it properly and give it sufficient area. Now, one shed, for example, 2 tons of dry solids around, which caters around 20 ml STP.
Yeah,
It needs
get your point. Get your point on the moisture content. Get your point on the pathogen removal through the drying process. But the question why standards are not getting notified is also because of the presence of heavy metals. That's the argument that comes up with everywhere. So I just want to know from your experience, when you do the sampling, whatever sampling you've done, are there high presence of heavy metals in the raw sludge coming out?
In some cases, sir, where the, truly speaking, where the industrial water gets mixed with the sewage, we get this failure, you know, where heavy metals will be more. You will not get, you will not get a class A certificate truly.
So what do you do in that situation?
We don't do, we specify that it is not, you're not achieving class A sludge. It's not to, you know, cover anything.
So, cover it.
It's not.
Okay. So
see, the main this process they are using is by their society, the industrial societies. This sludge is huge, so they are reducing the volume during transportation by using this technology. They are using this because of that.
Yeah,
and
but
along
the concern is that it should not contain the so-called heavy metals above the permissible limit, and that's a conversation around standards come into play. So, Dr. Banerjee, would you like to comment on this? You saw 3 presentations. One is Mr. Lalit has spoken about it, Mr. Veer Lakshmanan and Mr. Venkatrao really monetizing it. So what are your concerns? While all of them are focusing on the pathogen removal, Mr. Venkatrao mentioned that wherever there is a heavy metal concentration exceeding a certain limit, then they do what is called the dilution by adding another substrate into it. Of course, we didn't discuss what is that substrate, but generally mentioned about it. Do you have any comments on the presentations on the technology side, and what are the concerns you have with regard to standards?
With regards to pathogen, if you are talking about the first and the third technology we spoke of, whether it's the Covestro or the last one what we spoke of, if the temperatures, the ideal temperatures are reached, which is around 80 to 85, 60 to 65 degrees, and it stands for a few number of hours, it's obviously possible that the pathogens would be killed, especially the bacterial pathogens would be killed. And this procedure, if it goes for prolonged period of time, I'm saying consequently for 8 days minimum, obviously the seized forms of the elements will also be killed. But when it comes to the heavy metals, yeah, it is a concern because metals at this stage after the treatment, if what is happening is because of the dewatering and the further concentrating, the metals may get concentrated. But as Sir was saying, I mean, Mr. Venkat was saying that if it depends from sludge to sludge. For fecal sludge, if it's purely fecal sludge, we need not be concerned much about heavy metals because human waste does not have that much of heavy metals. We don't eat heavy metals, so it's probably our waste will not have that much of heavy metals. But when it comes to STP sludge, if the source of the sludge, STP is, I mean, where the sludge is coming from or the sewage is coming from, is from some kind of an industrial sewage is coming in or industrial effluents are pumped in, there are chances that heavy metals will be there. And when sludge is being concentrated or treated, they will build up. The concentration will build up. So that is, again, comes to the part of monitoring, which we were speaking. So that monitoring has to be a concern.
Thank you. Thank you very much. So friends, we heard about Ms. Mafalda speaking about ecosystem for developing biosolid reuse. We had Dr. Banerjee speaking about different standards and various constituents of the sludge and the potential treatment systems. And we heard about 3 live examples of how technology providers are actually solving the problem of both pathogen removal as well as to some extent the heavy metal concentration through dilution. We can take maybe 1 or 2 questions and then we can close the webinar. The proceedings, the presentations, all of this will be shared with you, and we can have a round of discussion subsequently as a part of this. Okay, Uday Singh, would you like to ask any question? I see your hands up, Uday.
Hello, sir. I am Yashwant Singh Gautam. I'm Uday Singh's son. So, I'm studying in Biosolids Engineering College. So
Yeah.
I have been studying on sludge. So we have been working on sludge, using it as a brick in construction material. So we have tested some parameters like the physical and chemical. So we while testing the physical parameters, we have achieved good results. But the chemical results, there are traces of heavy metals. We couldn't, make it a solution. So, is there any way that we could is there like a test, sir?
Yeah. So, Dr. Banerjee, would you quickly respond?
Yeah. So for sludge, if you want to test for heavy metals, you would need to go for two kinds of, you'd have to have access to some kind of instruments, which is called atomic absorption spectrophotometry or a plasma spectrophotometry, ICP. So by any of these, preferably it's, atomic absorption spectrophotometry. You have to use the sludge, you have to incinerate, you have to burn it down, and the minerals will stay back, that is the metal will stay back, and you have to compare it with the standard metal solutions that are there. It's a bit kind of sophisticated instrument. If you have access to any of the university central laboratories, you can send in your sludge and you can get it tested there, child.
Yeah, thank you, sir.
Thank you. Any other questions? Any quick questions from anyone on the standards or on the technologies or areas of improvement? So I think we have exceeded the time. Thank you very much, all the participants, for joining this discussion. This is just a work in progress. As I said, we don't have complete answers for everything, but the standards have to be gradually, I would say, notified over a period of time while we develop the body of evidence of what is the level of concentration of heavy metals, what is the level of concentration of pathogens, post thermal treatment or post solar drying. So I think this has to go concurrently. And this is the effort we are trying to make in partnership with ADB, in partnership with Ministry of Housing and Urban Affairs, CPHO, and all the state government partners. So thank you very much for joining us today evening over the weekend. And this conversation will continue till we meet next time on a different subject. Thank you very much for joining and have a great weekend. Over to you. Priya, any last comments or we close the webinar?
No, sir, I think we can close it. So I think everyone has shared their thoughts about how it is important to have the standards first to, complete the process of this circularity we are talking about.
Yeah.
So
thank you very
I
much.
think, yeah.
Greatly appreciate all the speakers for taking out your time. And Mafalda, I don't know which time zone you are in. Thank you very much once again. Bye-bye.
Thank you.
Bye.
Thank you. Bye.
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 Thank you.